Hello everyone. So today we're going to be talking about lecture 13, which you're going to find it in your book in section 2.8. Today's lecture is about related rates. So related rates is actually when you differentiate with respect to time. So let's first understand what is dy by dx. dy by dx is the rate of change of y, the numerator, with respect to the parameter x. So in simpler ways, if x is changing, what would be the change in y? So what if I'm interested in time? So I want to know if time is changing, what is the derivative or the change in the y value? So then we call it related rates because you're actually interested in the rate of change with respect to time. Example of this is dx by dt, change in x as time changes, dv by dt, changes in volume as time is changing, dA by dt, changing in area as time is changing. So what are we gonna use to solve the related rates problems? It's very important that we find an equation. In the problem, it will be talking, it's usually problems, word problems, text problems. You have to find a relationship between the variables he is discussing. Then we need to find the rate of change of the quantity with respect to time. So this equation, you will differentiate it with respect to time. And we will use implicit differentiation. So here is the strategy to solve the related rates problems. First, you need to read carefully. If you can have a diagram or a drawing that represents what you're reading, it will help you a lot. Then you will start to give symbols to any mentioned quantities in the problem. If he's talking about the distance, you would call it x. Talking about an area, you would give a symbol a. Then you will write an equation relating various quantities, and we will use algebra or geometry to find the relationship and to eliminate variables as well. Then we will differentiate with respect to time. Finally, we will substitute. You need to differentiate first, then substitute with the given information. And you will always find two rectangles in all of the slides. The first one, what is given in the problem, what is required in the problem, and then the three steps that we would need to do in all of them. The equation, how I will differentiate it, and then I will substitute. Let's go to an example to understand. Example 1. I have a point xy, it's moving on the curve xy equals 6. When p reaches the point 2, 3, its dx by dt is 5. Find dy by dt at that time. Okay, let's check what's given, what's required, and then follow the steps. It's very systematic. What is given is at x equals 2, y equals 3, the rate of change of x with respect to time will be 5. Here it is. What is required is dy by dt at x equals 2. Alright. Here is the three steps. Equation. What is the equation? It's already given. You don't need to work it. It's xy equals 6. Then, second step, I will differentiate it with respect to time. Third step, I will substitute with the given input. Let's see. Equation, differentiate. So this is the product of two functions. So it is first derivative second plus second derivative first. 6, its derivative is 0. Then I will substitute in this differentiated form. I'm having the value of x, y, and dx by dt. So the only unknown is the required dy by dt. You do the calculation, it's negative 7.5. What is the negative stands for? A negative means that it is actually decreasing. So the change in y with respect to time is decreasing. With time, the value of y is actually decreasing. Example 2. A 10-feet ladder is sliding down the wall. Here is the wall, and here is the ground, and this is my ladder. I put the 10 feet, it will not change, it's a constant, so I put it here. If the ground touching point is moving at 5 feet per second, if this ground touching point is moving at 5 feet per second, this ladder is falling down, so most probably this point is going down, and this point is going to the right. So here is the symbol x for this distance, and I said that dx by dt is 5. Find the speed at which the wall touching point is moving, this point. So I gave this a symbol of y, and I said it's required to know what is dy by dt. So find dy by dt when the ladder makes a 60 degrees angle with the ground, when this angle is 60. Alright, here is the given info. The height of the ladder, the rate of change dx by dt, and he wants dy by dt at theta equals 60. So we have 3 steps to do. Equation, and a relationship that binds between x and y would be Pythagoras. It's a triangle, a right angle triangle, so x squared plus y squared equals 100. So this is the equation I'm going to use. I will differentiate it with respect to time, and then I will substitute. So here is my differentiated equation. I differentiate it, and then I need to substitute. X equals 5, theta equals 60, but actually I need to substitute for y. So what can I do? I need to find a relationship between x equals 5 and theta equals 60 and y. So I just use sine 60, 60 at this angle, sine 60 equal opposite, which is y, over hypotenuse, which is 10. Sine 60 equals y over 10. So I got the value of y, and I resubstituted in this equation with all the given information, and I found that dy by dt equal negative 2.88 feet per second. And negative means that the change in y is actually decreasing with time. So in this example, a paper cone gets filled with water at a rate of 5 meters cubed per minute. If you are not sure what quantity this is, just look at the units and you will find that this is meter cubed, which means volume. So this is dV by dt. The cone height is 4 meter. Here it is, 4 meter. And the radius is 2 meters. And the volume equation is also given. How fast is the water height? How fast water height? He wants dH by dt, increasing when h equals 3. And then he's asking about how fast the radius, so dr by dt, at the same time. So here is the givens. We know that dv by dt is 5, the cone height 4, cone radius 2, the equation is also given. I'm required 2 quantities at h equals 3. This is the equation I will use. I will differentiate with respect to time, and I will substitute. So if I start to differentiate, you will get that we have 2 parameters, r and h. So I'm going to have dr by dt and dh by dt if I differentiate. So I'm going to have 2 unknowns. So I need to get one of them in terms of the other one, so that at the end I just have one unknown. If there is a relationship between the r and the h, if you look at the cone, yes. We can use similarity of triangles. You see this big triangle, and we have this small triangle. And if we do similarity of triangle, we can find that r over h equals 2 over 4, or r equals h over 2. So this relationship, I will use it, and I will resubstitute in the original equation, so that I would end up with only one parameter, which is 1 over 12 pi h cubed. This is now my new equation. I'm going to differentiate with respect to time. So dv by dt equals 1 over 12 constant. Pi is constant, so they are outside. And then I'm going to differentiate h cubed. It's going to be 3h squared dh by dt. And I will substitute with the givens, and I will find dh by dt. Here he wants dr by dt. How to get now I need to get h in terms of r. In the same similarity of the 2 triangles, this ones, I will get that the h is equal to r. So this is now my new equation. I will differentiate with respect to time and then substitute with the given information, and I will get the dr by dt. A positive sign always means that the rate of change is increasing. Example 4. I have a street light mounted on top of a 15 feet pole. Here it is, the light, and here is the 15 feet tall pole. A man 6 feet tall, here is the man. He is walking away, so he is walking to the right with a speed of 4 feet per second. So if I give a parameter x for this distance, dx by dt will be 4. Is it increasing? Yes, the distance is increasing, so it's going to be positive 4. How fast is the tip of the shadow? The tip of the shadow is the tip of this triangle over there. This is the tip of his shadow. Moving from the pole. So we are comparing between the pole and the tip of his shadow. So we are talking about the distance y. So here are the givens: the pole height, the man height, the rate of change of x with respect to t, and we want dy by dt at x equals 50 feet. So what equation can I use using this triangle in order to have a relationship between the x and the y and the dy by dt? I can use similarity of triangles. So y minus x over y equals 6 over 15. Here is the 6 over 15. And then I will differentiate and substitute. So using similarity of triangles with the same similarity of two triangles, I will end up with this relationship: y equals 5 over 3x. I will differentiate it with respect to time. So dy by dt is 5 over 3 dx by dt. I will substitute, given that dx by dt equals 4, and I got dy by dt. There is a very important note here from this equation, is that dy by dt just depends on dx by dt. So the man distance from the pole did not matter. Only his speed affects how fast his shadow moves. The x was not in the equation, so it didn't matter the distance where the man is standing. What actually matters is the dx by dt, how fast he is walking away from the pole. So example 5. Air is being pumped to a hollow balloon. The volume is increased by a rate of 100 centimeter cube per second. So I have here a new parameter: dv by dt is plus 100. How fast is the radius increasing? Radius increasing, so he's asking about dr by dt if the diameter is 50. And he gave us also the equation of the sphere. So I have the equation, I will differentiate it, I will substitute with the given diameter or radius. Here it is, the equation. I will differentiate dv by dt, 4 over 3 pi. R cubed will be 3r squared dr by dt, and I will substitute, and here is dr by dt. It's positive, means that it is increasing with time. Example 6. Example 6, here we have two cars, car A and car B. Car A is moving west, while car B is moving north to meet at an intersection. And he is asking about the distance between car A and car B, z. So he's saying car A is traveling west at 90 km per hour. It's traveling like this. Since the distance to the intersection is decreasing, so it is actually negative 90. Car B is traveling north at this rate. So this is dy by dt, negative 100. I give the symbols x for car A and symbol y for car B. Both of them are going to the same intersection. What rate are they approaching each other? What rate is the two cars approaching each other? This distance between the two cars, I gave it z. So he's asking about the rate of z, so dz by dt, excuse me, when car A is 60, so x equals 60, and car B is 80, so y equals 80. So I put my givens, the two rate of changes of the x and the y, and the required dz by dt. I can say that the relationship, it could be Pythagoras, x squared plus y squared equals z squared. Another thing I need to make sure of it is that I have some quantities in meter and others in kilometer per hour. So I need to use only the same unit. So I think I will change the 60 and the 80 meters into 0.6 and 0.8 kilometers, so that at the end I'm dealing with all units. So here is the equation, Pythagoras equation of my triangle: x squared plus y squared equals z squared. I differentiate with respect to time. Then I will substitute the x and the y, but I don't have a value for z. Since I don't have a value of z, I need to find it. So I will use the same Pythagoras equation, given the value of x and y, and z will be the square root of x squared plus y squared, and I found it here, it's 0.1 kilometer, and I'm back to the equation to substitute. I found that dz by dt is negative 134 km per hour. So actually it is decreasing with time. This makes sense. If they are getting closer to each other, the z will also be smaller. Here is our last example, example 7. So we have a man walking along a straight path at a speed of 1 meter per second. So this man is walking in this direction. So I will call this x, and dx by dt is 1.5. A searchlight source is located on the ground 6 meters beneath the path of the man. So I have here a source 6 meters below the path of the man. A light is focused on the man. This light source is actually, this is the light radiation, and it is focused on the man. As he's walking, the light is also following the man. So at what rate the light is rotating? Rotating, we're talking about an angle. So this is the angle, this is theta, this angle, theta, and he's asking about the rate of its change. So he's asking about d theta by dt. When the man is 8 meters from the point on the path closest to the searchlight. So the man x, when x is equal to 8. I put here my givens and the required d theta by dt at x equal 8. So the first thing, I need an equation. I thought the easiest one to use is tan theta. This is my theta, is opposite, so it's x over adjacent, which is 6. Then I will differentiate, and then I will substitute x equals 8. Here is my equation, and then I differentiated with respect to time. Tan will be sec squared theta d theta by dt. X over 6 will be 1 over 6 dx by dt. So I need to substitute x equals 8, but I don't have a value for theta. So what I will use is I will go back to this original equation, and using the givens, which is x equals 8, I will get the value of the theta at x equals 8. So I said tan theta is x over 6, which is 8 over 6, and I got theta is 53.13 degrees. Back to my equation, now I have everything. I will just substitute and get the value of d theta by dt. This was our last example in the related rates. It's easy and it's very systematic. You always need an equation, you differentiate with respect to time, and then you substitute. It's very important to read carefully. It's very important to know what is given and what is required. And it's very important also if you can make a graph or a small drawing of the text that you are reading. It will make it very easier for you. All right, see you next class.